In today's video, we'll be taking a long overdue look at using Shelly devices for smart home lighting control. Historically, when I've needed some sort of relay or smart switch type device, I've always just gone towards sawn-off devices and flashed them with Tasmota. And that's really just because when I started out doing this, that was a normal thing you would do. However, these devices from Shelly came onto the market a few years after I started doing that, and while I've never really looked into them before, these look like an absolutely brilliant option. Because Shelly offer an absolute ton of different devices, smart relays, dimmers, input modules, LED strip controllers, all that sort of stuff. But with these, the stock firmware is absolutely brilliant for a self-hosted smart home. Because not only does it support obviously cloud connectivity where you can use a cloud app if you want, that's completely optional. It also supports MQTT, different HTTP APIs for things like Home Assistant integrations, and even seems to support some sort of local scripting functionality, allowing you to create little scripts that run on the device to potentially automate certain functions without needing external servers to control them. And I've got quite a neat idea for that. So I have a bunch of different projects lined up for these devices, but in this video we're going to be taking a look at two of these, and the other ones will come up in future videos. So today what we're doing is installing smart lighting in my hallway, and we'll also be replacing the kinetic wireless switches I'm using to control smart bulbs in my living room and bedroom with Shelly devices connected to switches that'll act as a switch input to my smart home system. So what we'll do in this video is we'll talk about the two different use cases I'm using these for. For each of those we'll talk about the hardware we'll be using. I'll then go away, show me installing them, install them, get all the hardware installed. I'll then do the software configuration and smart home integration off camera, and then we'll come back and take a look at the setup once it's finished and see how it all works. So the first place we'll be installing this is in my hallway. Now if you've seen my previous videos, you'll have seen a video where I installed kinetic wireless switching in the hallway to accomplish a very similar task to what I'm doing now. However, if you've seen my video after that, I experienced a reliability issue with those switches where I don't feel they're reliable enough. I had one completely fail outright, found another one that was about to imminently fail, and I imagine the others are probably about to fail as well, so I just don't trust them long term. So I wanted to replace them with something different. Now to make this video a bit clearer to people, what I'm going to do is rather than replace the kinetic system with these directly, I've put the hallway back to its original configuration, and we'll be installing these essentially onto a completely stock install as this place was wired when it was built. So I'm not going to be trying to show me taking the kinetic system out and putting these in instead. Basically pretend that kinetic thing never happened, and I'll be installing these from scratch. So what I have in my hallway is two-way switching. So there's a light switch by the front door, a light switch next to the living room door, and both of those control the lights. So you can use either switch to turn the lights on or off. It's just standard two-way switching. But in the hallway, I also have a display cabinet which has an LED strip in it. And while that is fed from the lighting circuit, it's not switched by the same switches that control the room lighting. It just wouldn't have been practical to get a cable in. So instead, it's controlled by a switch on top of the cabinet. So with this setup, I want to accomplish a few different things. First of all, I want the lighting in the hallway to be able to be dimmed. Second of all, I want to be able to control the display cabinet at the same time as the main lights in the hallway. So the light switches in the hallway also turn the display cabinet on and off. I also want to add an additional switching position next to the bedroom. There's an existing light switch there for the hall cupboard, but no switch for the hallway lights. And it would be really useful to be able to turn the hallway lights on and off from the bedroom door rather than having to walk all the way across the hallway to find another switch. And I'd ideally want to do this without running additional cabling and trying to get a cable into that switch. So I'm going to install smart switching so I can have a switch input next to that door that goes through the smart system and triggers the lights. So I want to be able to add an additional switch next to the bedroom door. And the final thing I want to do is have it integrated into my home automation system. So now I have my alarm system integrated with my home automation system. I want to set up where I can come in from being outside, and when the alarm is armed and I open the front door, it automatically turns the lights on. And likewise, when I arm the alarm and leave, it'll automatically turn the lights off. Just a little quality of life improvement. So with that all explained, let's talk about the hardware we'll be using. So for this, we're going to use three different Shelly devices. The first one is the Shelly Dimmer 2. And as the name suggests, this is a dimmer. So we can take this out and look at what the device is. And this is basically a smart Wi-Fi dimmer module. So we're using these to control the main ceiling lights in the hallway. It's a set of, I think, 5 GU10 downlights that have dimmable bulbs in them. So this is the dimmer module. You've got a bunch of terminals on it. So you've got live, neutral, an output, which will go up to the bulbs, and a pair of switch inputs. So with this, what we'll do is we'll wire live and neutral into this. The output will then obviously go up the bulbs, as you'd expect. And then we'll use one of these switch inputs to send switch controls from the two different switching positions, the one by the living room door and the one by the front door, into this to control the dimmer. So with this one device, I'll be able to control the existing hallway lights and dim them up and down from the two switch positions without any additional hardware. Now, of course, the current switches are just regular rocker switches, just regular two-way switches that latch in each position, which isn't ideal for a device like this. I mean, you could probably make it work, but I personally don't really like having switches that look like they're on when they're actually off. I just get the standard two-way switching. Plus, with this being a dimmer, I want the ability to hold a switch down to dim the lights up and down. So instead, what I'm going to be doing is installing these retractive switch modules. These are MK ones, just because I've got MK light switches, so these will fit into the existing grid system I have. And the way these retractive switches work is they look like normal light switches, but when you click them, they spring back up. They're just momentary switches. So what I'll be able to do is wire these into the switch inputs on this, and it means that when I press this, it turns the lights on, and I press it again, it turns the lights off. They always look like they're in that position. They don't ever look like they're in kind of the wrong position, being on or off. And because they're retractive, I can then hold them down to dim. So I'll need to figure out a different configuration and how I prefer to use it. But I can either have it that, say, I press it once, it turns on full brightness, I hold it, it turns on dimmer, or maybe when the lights are on, I'll hold it and it'll dim up and down. I'll be able to do something like that. So I'll figure that kind of setup out later. Now, the other option you could do, instead of using a switch like this, is to get what's called a center off retractive switch, which can basically be clicked in either direction. So you can click it up or click it down. That could potentially be better, and as you can see, this does have two separate switch inputs. So you could use that as two separate switches and either hold the up button to dim up and hold the down button to dim down. That could be nicer, however it won't really work in my particular setup here. Because as I mentioned, I have two-way switching between the front door and the living room door. This device will be installed at the living room door because that's where the wire or the cable going up the lights comes from. However, between the two doors is a 3-core earth cable. And that will need to carry a permanent live and a neutral to power the Shelly and the lights, meaning there's only one spare core as a switch live coming from the front door switch to the living room switch. That means I can only really have a single switch at the front door. So while I could probably have a two-way center off retractive switch at the living room door and a regular retractive switch at the front door, I may as well just use these everywhere. I'm not too bothered about dimming too much in the hallway. Realistically, what I care about is more having full brightness versus dim for like a night light kind of thing. I don't really care about setting particular brightnesses regularly. So what I think I'll probably end up with is a system where if I press this once, it turns on full brightness. If I hold it down, it turns on dimmer. Or maybe I do something with time of day. I'm not quite sure yet. But yeah, that's how it works there. I'm going to be using these standard retractive switches, but with the dimmer module, you could actually connect two different switches, either two of these or some sort of center off two-way switch, which could also work. The next device we'll be using is the Shelly RGBW2. And this is an LED controller. So as you can see, it's RGBW, so it's designed for RGBW LED strips, but it can also just be used with standard LED strips. So the LED strip I have in the cabinet is just a regular, I think 12 volt LED strip. It's not even RGB or color changing or anything. It's just a standard LED strip. But the reason I'm using this, rather than say using another dimmer like this, is purely because that LED strip that already has a driver there, but it's a non-dimmable driver. So if I wanted to dim it with a mains dimmer like this, which is designed to dim the mains, I would need to replace the driver with a dimmable one. On the other hand, with this, I can install this after the driver, I can install this between the driver and the LED strip, and this will dim the LEDs directly. I also feel this may be more reliable, because sometimes dimming LEDs, especially by dimming the mains, isn't the most reliable thing ever. So potentially this might be more reliable because this is actually controlling the LEDs itself. This is taking 12 volt in and feeding 12 volt out to the LEDs and dimming it. And even though this is RGB, so it's got a bunch of different outputs, you can just use one of those channels just to control a single LED strip. So it'll be interesting to try this out and see how it works. And I've also got another plan for using one of these in the future in a slightly different project where I will be controlling a bi-color LED strip. So it'll be interesting to check it out before I buy another one to do that project. So that's that device there. Interestingly, it's not quite as refined. I mean, this is a bit more printed on. This is kind of more embossed, but doesn't really have much labeling on it. That's just sort of stuck on the back, but it's fine. So that's it there. Comes with a sort of wire as well. Don't know what that is. Let's see. It comes with a thing. What is this? It comes with a thing. I'm going to look at the manual and I'll quickly figure out what that is and come back. Okay, so I've just figured this out. This seems to be some sort of opto-isolator for switching this device using a mains voltage switch. Like the dimmer device, this has a switch input. You can probably just about make it out here. It's quite hard to see the text on this device because it's all kind of molded into the plastic. But you can just about make out here on the right hand side, there's this terminal here labelled I, which is a switch input. So what you seem to do is you can put a switch between this and ground, and that allows you to feed a switch into this. But also, this being a low voltage device, that's designed for low voltage. But with these devices, what you can do is you can feed 230 volts into its switch input and use that for switching. So what this device allows you to do here is put mains, so 230 volts or mains voltage on these black wires here, then put the black and red wires between ground and the switch input, and basically use a mains voltage switch to switch this low voltage device. So that's what that is there. It's pure, imagine some sort of opto isolator or something in there. So it's neat to get that. Surprised I actually included that. That's quite a neat little thing. I won't be using it, but it's nice to get it, I suppose. So that's what that is there. And you get a pretty comprehensive manual that details all the wiring for this in all different scenarios. So you can see here, that's where you'd install that opto isolator type device. Or over here, you can see where you're using it on the other side. Yeah, where you're kind of just switching it at the low voltage side. So there's two different ways you can do it. So yeah, DC switch wiring and AC switch wiring. So that's what that is there. Cool, that makes sense. And then the final device I have is the Shelly i4. And I'll be using this for that additional switching position I'll be adding. The Shelly i4 is quite an interesting device that I really wanted to take a look at. It's essentially purely an input. There's no outputs on this, no relays, nothing like that. It's purely a switch input and can take up to 4 switches. It's available in 2 different versions, either low voltage version or a mains voltage version. This is the mains voltage version, so it's 110 to 240 volts AC input. You simply feed live and neutral into here, and then put a switch live to each of these 4 switch terminals, and it'll just allow you to have 4 switches feeding into this. Now for my particular setup here, I'm only going to be ever using one of these switch inputs, which is just one of these retractive switches. So realistically, I wouldn't necessarily need to use the Shelly i4. I could really use any Shelly relay type device, decouple it so the relay isn't being controlled by the switch input, and use that as a single channel switch input. However, this is probably a little bit cheaper than those, and I kind of wanted to try it out because it looks like quite a cool device. So yeah, this doesn't have any kind of output or dimming or switching type capability. It just allows 4 different switches to be fed into this and act as an input for up to 4 different switches. So yeah, we'll be using this to add that additional switch position in the hallway. So there you go, that's the device we'll be using for the hallway. The Shelly Dimmer 2, the Shelly RGBW2, and the Shelly i4. So now before we go and install that, let's take a quick look at what we'll be doing in the living room and bedroom as well, because that'll be a much simpler project. So for the living room and bedroom, as I mentioned, what we're going to be doing is using Shelly devices to act as a switch input to my smart lighting. So in both those rooms, I have standard smart bulbs throughout the room, and all I want is a switch by the front door that controls those through my home automation system. So of course, when I first say that, you're going to immediately think, well, go for the Shelly i4 because it's designed purely for input, doesn't have any relays or anything, and this would work perfectly. And it would. However, for those rooms with smart bulbs, I want some sort of physical override to control the bulbs. That's because if my home automation system goes down, the server goes down, the network goes out, or even just doing maintenance on it and have to take it down, I still want a way to control the lights in each of the rooms. Currently I do this by having a key switch on the wall next to the kinetic switch. And that works quite well. It means that in the event of the whole system failing, the smart home system going down, I can take a key, stick it in the key switch, and use that to control the power to the bulbs themselves. And the way the particular smart bulbs I have work is if the mains is cut and reapplied, the bulbs will automatically turn on. And with that key switch, I can use it like a standard light switch in an emergency. But I'm not the biggest fan of how they look. They definitely work really well as an override, and I would definitely say if you're ever installing kind of smart remotes or anything like that, and you're relying on smart bulbs, it's good to have, say, a key switch as an override instead of just linking out your regular switch. But what I thought I wanted to try out is rather than using a Shelly i4 and keeping the key switch, what if I got rid of the key switch and instead used a Shelly relay? Because with this, I could use the relay to control the smart bulbs and set something up so that, say, if I hold the switch down for 10 seconds, it triggers the relay rather than relying on the home automation system. So in the event of the system going down, I could hold down a button, hold down the switch for 10 seconds and physically control power to the bulbs as like an additional override. And I'm hoping I can accomplish that with scripting on this. I might even be able to do something even more advanced. Say, for example, if the Shelly is disconnected from the network or can't connect to an MQTT broker, it automatically reverts to standard switching. So even just pressing this turns this power to the bulbs on and off. That might be quite interesting to try out. But yeah, I kind of want to give that a go. Try not having the key switches and instead just rely on a single retractive switch connected to one of these Shelly relays that normally controls the smart bulbs through the home automation system. But in an emergency, I can use the same switch to control the relay in this to control the physical mains power to the smart bulbs. So that'll be interesting to try out. And as you can see for this, I'm using the Shelly 1 Mini, which is a new device that Shelly seem to have brought out. Essentially, Shelly 1 is their standard, or Shelly 1 Plus is their standard basic relay. It's a single channel relay with a single switch input. But they've released this mini version. It's the same thing, just a lot smaller. And this could be quite nice because trying to install these things in cramped back boxes can be a bit fiddly. So it could actually be quite nice to, well, have a smaller version of it. So that's it there. And as you can see, it is absolutely tiny. So if we compare it to a full-size Shelly Plus one, you can see a huge size difference. See how much smaller the Mini is. Now there is a slight loss of functionality with going for the Mini. The full-size one can run on mains voltage or 12 volts or 24 to 48 volts, so it can run on lower voltages. This is mains voltage only. But other than that, it works basically the same and is a much smaller device, which should be really good for installing in a cramped back box. Especially in my living room and bedroom, because I've already got smart touchscreens installed above each light switch as well. Those take a mains feed from the light switch. So that's an additional cable coming out of that back box that's joined on inside the back box. And it means that those light switches, I think the bedroom has about 4 cables coming in and out of it, which gets quite cramped. So actually having a much smaller relay device will be really easy to fit in there, versus this that would fit fine, but would be a bit harder to install. So I thought these mini ones would be quite nice to try out. And they're a bit cheaper as well, so got 2 of these to try out as well. So there we go. That's all the hardware we'll be using for this project. For the hallway, we have a Shelly i4, a Shelly Dimmer 2, and a Shelly RGBW2. And for the living room and bedroom, we have a couple of Shelly 1 Plus minis, or Shelly Plus 1 minis. Some combination of those words. That's the hardware we have there. So the first thing we'll do is install the hallway. So we'll go out the hallway, take a look at what we have right now, talk about how we're going to install these new devices to replace the existing two-way switching, get them installed, and then get them set up. And then we'll do the same for the bedroom and living room. So to start off with, here we have the switch at the front door. And needless to say, if you're not comfortable doing this and you're not competent with electrics, don't try this at home. But what we have here is a fairly standard two-way switching setup. So this is the switch by the front door, and into this we have 3 cables. We have a pair of twin and earths coming in and out, so they're carrying a permanent live and neutral into the switch and then back out again to the next room. And then we have a 3-core earth that comes from the switch to the other switch by the living room door. In terms of connections, the 2 permanent lives, the loop in and loop out, connect into common on the switch. Then out of the 3-core earth, the black and the grey cores, or the black and the brown cores, connect into terminals 1 and 2 on the two-way switch. And that carries the 2 different switch lives over to the other switch. Then for the neutrals, they're all common together in a Wago here. So we have the regular blue neutrals of the feed in and feed out coming into that Wago. And then the grey core out of the 3-core is also connected into this Wago, which takes neutral over to the other switch. And then here we have the switch by the living room door. And into this we have 2 different cables. We have the 3-core earth coming from the other switch, and then a piece of twin and earth that comes from here up to the lights. The neutrals are just common together in a Wago again, so we have the grey from the 3-core earth comes into the Wago, and the blue from the twin and earth that goes up to the lights comes out, so that basically passes the neutral up to the lights. As before, the brown and the black from the 3-core earth go into terminals 1 and 2 on the switch, that's the two-way switching, and then out of the common on the switch, we have the live that goes up to the switch, up to the lights. So we have a single cable coming out of the common, and that's the finally switched live that goes up to the lights. And that's standard two-way switching. So now let's talk about how we're going to modify this to set up the Shelly Dimmer. So if we take a look at the Shelly Dimmer module, we need a permanent live and neutral to power this. We then have an output that goes up to the lights, and then we have the switch inputs. And the switch inputs need a switched live, so basically it needs to connect a live through the switch and into one of these switch inputs. And I want to have a switch both here and by the front door. So how are we going to do this? Well, starting off by the front door, what we need is to have a permanent live that goes from here over to the other switch position. So what we'll do is we have the permanent live in and out of this switch that feeds into this switch in and out to the next room. So what we'll do is we'll take one of the cores out of the 3-core earth, probably the brown, and common it into a Wago with these here. So that'll feed a permanent live over to the other switch position, which will power up the Shelly Dimmer. The neutrals we won't touch. All we need to do is just get a neutral over to that other position, which we already have here, so we won't need to change anything there. But what we also need is a switch live from a retractive switch here to go over to that other switch position. So for that, what we'll do is I'll install a retractive switch in here, connect the black out of the 3-core earth, just to use it as a switch live, into that switch, connect a permanent live into that switch as well. So all that switch will do is switch a permanent live through to a switch live, and that switch live will be the black in the 3-core earth that goes over to the other switch position. So at the other switch position, what I'll have is the 3-core earth coming in, the grey will be the neutral, the brown will be a permanent live, and the black will be a switch live from the retractive switch here. So whenever that switch is pressed down, the switch live over there, over the other switch will become live, and when I release the switch live at the other switch will become dead. So here we are back at the living room door, so let's talk about how we're going to change this. First thing we obviously need to do is get a neutral to power the dimmer, so all we'll do is we'll replace this two-way Wago with a three-way Wago, and have a wire that comes out of that Wago into the neutral terminal on the dimmer. We also need a permanent live for the dimmer, so we'll just take that brown core out of the 3-core earth and use it as a permanent live to power the dimmer up. The switch live that goes up to the lights will come out of the output of the dimmer, which I think is the O here. And then for the switch input, what we need to do is feed the switches into the switch input, just one of these. So as I mentioned before, I'll have that black core out of the 3-core earth will be a switch live from the front door. That'll come into the switch input. And then I'll put another retractive switch in here, which once again will have a permanent live going into it, a switch live coming out of it, and that will also go into the switch input. So that should be fairly simple. So what I'll now do is I'll go away off camera, take all this apart, get this all wired up as I've sort of described here, then we'll come back and hopefully it'll work. Okay, so it's all now connected up. So here we have the switch in the hallway. Doesn't look like much has changed, but what I've done is I've replaced that module with the retractive module, so that's now a retractive switch in there. And what we now have is into the common connection, we have the feed in and feed out lives going in and out as before. But we also have is the brown core out of the 3 core is also going into that common, so that's connecting a permanent live to that brown wire that goes across to the other switch position. Neutrals haven't changed, they're also common together in the WAGO, so the brown core, or the grey core out of 3 core in earth is carrying the neutral over to the other switch. And then the black core out of 3 core in earth is going to the normally open contact on the retractive switch. So it's labelled make on this, so when you click the retractive switch down, the permanent live here gets switched through to the switch live on this black wire here. So as I described, the black wire is carrying a switch live, brown is carrying a permanent live, and the grey is carrying the neutral over to the other switch. So now it's going to see the more interesting stuff, the other switch. Next up, here we are at the switch next to the living room door, and we've got the Shelly installed. So I'll try and roughly explain how this is all wired up. So as you can see, we've got the neutrals at the back as before, all common together in a WAGO, but I've upgraded that to a three-way WAGO, so that we have the neutral comes in on the grey, goes up to the light, and also comes out to the Shelly. And we can see that new blue wire that comes into the Shelly, giving it a neutral. The brown core out of the 3 core then comes into the live terminal in the Shelly, powering it up. The output of the Shelly is connected to the live that goes up to the light, so that's the switched and now dimmed live up to the lights, comes into the output terminal on the Shelly at the right hand side. And for the switch, what we have is we have a permanent live coming out of the Shelly into this common on the switch. All the live terminals on the Shelly are common together, so I'm just using it as an additional permanent live. Could really be connected anywhere, could be connected in a WAGO at the back to permanent live, but these are all common together as we come out the Shelly on a permanent live into common on the switch, and then come out of the top of the switch into the switch input on the Shelly. And then of course we've got the switch live coming over from the other switch as well. That comes in on this black wire here, so that comes into the output of this switch. So we've got the make contact on this switch, and I've just commoned that together with the switch wire going down to the Shelly. So that just means that both switches feed into the same input on the Shelly. So when either switch is pressed, this wire here becomes live, feeds live into the Shelly, and it receives a switch input. And that should work. So what we now need to do is get all this screwed back, get it all neatly put into the back box, check all the wires are still tight after moving them around, get it all sealed up, power it up, check it all works, and then get the Shelly i4 installed for the other switch position, and get the Shelly RGBW2 installed for the cabinet LED strip, and then we can set all this up. Okay, so it's all now installed and powered up and working. So I'm not done any setup in terms of the smart stuff. I'll do that once all the other hardware is installed. But even with it powered up, it does work as a dimmer. So if you press the button, lights will turn off. Pressing the button again, lights will turn on. With the lights on, if I hold the button down, it'll start dimming down. And then if I let it go and hold it again, it'll start dimming up. So when you hold it, it just does the opposite of whatever the previous dimming it did. When it gets to the top, it stops, which is quite good. I don't like dimmers where if it's at the full brightness and you keep holding it, then starts dimming down, because it can be kind of hard to try and actually find the absolute peak brightness. Whereas with this, because it'll stop when it gets to the top and stop when it gets to the bottom, you can actually easily hit the maximum minimum. When it's off, if you hold it down, it'll automatically turn on at the lowest brightness and then begin to dim up. And then if we've got it down at the lowest brightness, so if we turn it down really dim there, turn the lights off, turn it on again, it will recall the previous brightness level. But if the lights are off and then we double press the button, the lights will automatically turn on at full brightness. And this is just a sort of standard behaviour of the Shelly dimmer. So it works really well. So what we'll now do is we'll get the Shelly i4 installed to add that additional switch position, and then we'll get LED driver in for the cabinet. So here we have the switch next to the bedroom door, and this is where I want to add an additional switching position using the Shelly i4. So I've already swapped out the grid frame for a 2-gang one, so we can fit an additional module in here. And as you can see in this, we've got a single switch. But this is a little bit different to what you would normally have, because this is actually a double pole switch. All this does is the light in the hall cupboard. But the reason I'm using a double pole switch here is so I can have one that has a neon indicator in it. Because with this cupboard, it's super easy to switch the light on, close the cupboard door because it's on a door closer, so it automatically closes, and then completely forget the light's left on. So I put this switch here, which is double pole, and therefore it's got a neon indicator, so I can easily see if the light's been left on in the cupboard. So that's why the live and neutral both go through the switch. You wouldn't necessarily need to have the neutral come out of the switch for the light. It doesn't need to be double pole switched, but this switch itself will need a neutral connection so that neon can work. So essentially it's wired as a double pole switch, so the live and neutral both go through the switch. So the wires coming out the bottom of the switch go up to the light, and into the top we have the feed in and feed out as a neutral and live. So all I'll do for this is I'll come off the feed in and feed out with a live and a neutral, bring that over to the Shelly i4, and then connect the switch up to the Shelly i4 as well. Okay, so that's Shelly i4 now wired up. So we've got the retractor switch installed here, and then we've got the i4 here. We've got the permanent live and neutral going into the rightmost two terminals here, so that they come out the back of that double pole switch. And then we've got a permanent live basically looped out of this. So there's two live terminals common together. So we have a live that comes out of this into the switch, and then we come back out of the switch into the switch 1 input. So that's connected up. So let's just get this screwed back and get the LED controller installed. So there we go, that's all put back together, and I've powered it up and the Shelly's working, so I've got it connected to the network now and updating its firmware. So the final thing we need to do is install that LED controller up on top of the cabinet. Now, I won't be able to get the camera up there, it's right on top of the cabinet, right close to the ceiling, but I'll put some photos up just to kind of show what I'm doing. Essentially, all I have currently is a single 12-volt cable that comes out the LED driver directly into the LED strip. All I'm going to do is cut that and wire the Shelly LED controller in the middle. Obviously that needs to be in some sort of enclosure, so all I'll do is I'm just going to put a single guying surface pattress up there, put it inside that and put a blanking plate on top, and that'll do just to kind of keep it in some sort of enclosure. So you'll be seeing some pictures of what I've done, I just can't really fit the camera up to show that live. And then here's the finished result. We've got the LED controller on top of the cabinet. So what I'll now do is I'll go away, get all this set up off camera, and I'll come back and take a look at the setup working. And we're back. So I've now gone away, set up all the devices in the hallway, programmed it all, and got it working. The setup process was fairly simple. With each of the Shellys, when you first power it on, it starts broadcasting a Wi-Fi SSID that's just unsecured. You can connect to that, go to the default gateway IP address, which I think is 192.168.33.1, something like that. Pulls up a web page, and within there you can set it up to connect to your existing Wi-Fi network. With the Shellys, there seems to be two different generations of device. There's the newer ones, such as the Shelly i4, the Shelly Plus ones, those devices, I think the general ones have plus in the name, or there's the Generation 1 devices, such as the Shelly Dimmer and the Shelly RGBW controller. Generation 1 devices just connect straight to Wi-Fi network and then they work only on that. I found the Generation 2 devices continue to broadcast their insecure Wi-Fi network even when they're connected to an access point, so you need to explicitly go in and disable the access point on the device to get rid of that. But after doing that, they all work fine. What I also did was update the firmware on all the devices. It seems as though on the newer firmware with the devices, you can actually upload a file to the device's web interface to install the new firmware, but with the stock firmware, they all wanted to connect out to Shelly to download their latest firmware. Now for these devices, I keep them all on an isolated VLAN on a private wireless network that can't access the internet. So all I did for each of them was first of all connect to my main Wi-Fi network which can access the internet, let them all update their firmware, and then move them over to the IoT offline network. And with that, they all work. The dimmer was pretty easy to set up. I could log into web interface, and the first thing it asked me to do was do a calibration process. And what this does is basically work out how to dim all your bulbs. So it seems to just turn the brightness of the bulbs up and down, set different dimming levels, and measure the power consumption to work out when the bulbs are turning on and stuff like that. I found that for my setup that didn't work perfectly because I've got a bunch of different downlights connected to the same dimmer. So with its default calibration after calibrating it, I found that on the lower brightness levels, only some of the bulbs would turn on and some wouldn't. But all I needed to do for that was go into settings and set a minimum brightness value. And that way, when I set the brightness on the dimmer to 1 to the lowest brightness, it actually caps that to I think 8%. And at that point, all the bulbs turn on. The dimmer also has another really useful feature called warm up. And this is where you might have bulbs where even though they can run at a lower brightness, they can't turn on at that lower brightness. And that's the case here. These bulbs work all the way down to 8%, but if I turn them on, if they're completely switched off and I turn them on to 8%, the bulbs won't light up. But if I turn them on onto a higher brightness and then switch them down to 8%, they'll stay on. So with the warm-up feature, you can set a brightness and a time, and what that means is if you're turning the bulbs on to a lower brightness, it will first of all turn it on to that higher brightness for that period of time as like a pulse, let them start up, and then it'll turn them down. And with that set, it actually works. If I turn the lights on at a very low brightness, the bulbs will first of all flash at higher brightness for a fraction of a second and then dim down to the lower brightness. And that means they can turn on at a low brightness. So it's really cool to see how configurable this dimmer is. It's much more configurable than any other dimmer I've seen, especially like compared to a normal standard dimmer switch. It's actually pretty powerful having this customizability. The RGB controller doesn't have quite as much functionality. In particular, you can't seem to set a minimum brightness on that, which is a little bit annoying because I found with my LED strip, it flickers at very low brightnesses, and I can't really tell the controller not to turn it below that brightness. But of course, because I've used Node-RED to do all the automation with this and integrate all these devices together, I've just set that up in there. But that's just something to bear in mind that the RGB controller doesn't have any sort of minimum brightness functionality. The other thing I found with the RGB controller is it has two different modes of operation. One for controlling RGB LEDs and one for controlling white LEDs. If you set it to RGB, the interface gives you a colour picker. You can pick different colours and it sets those, and you can adjust the brightness value of the white individually. If you set it to white, on the other hand, what it does is essentially turns it into a 4-channel dimmer. So rather than having RGBW channels, you just have 4 channels. You can adjust the brightness of these individually, and that would work. Now, it doesn't seem to have a way to let you set a particular colour temperature if you're using bicolor LEDs, so you kind of need to calculate that separately. But for me, because I just have a single LED strip, I wanted to set it to the white mode of operation rather than the RGB mode of operation. And this is where I got a bit confused, because I was changing it in the interface, and then it says, once you've changed this, the device needs to reboot, and this can take 5 minutes. So I would do that, I change it from RGB operation to white operation, it would sit for a few seconds, and then just not change. It turns out that when you do that, it actually tries to download a new firmware image and reinstall the firmware with a different piece of firmware that operates on for white LEDs rather than RGB. And because mine was operating on a private network without internet access, it couldn't do that. So just something to bear in mind there, if you want to switch a Shelly RGBW controller from white mode to RGB mode or vice versa, you need to have an internet connection that the device can connect to download that new firmware. But after doing that, it works fine. What I then did was connect all the devices to my MQTT broker and use a Node-RED flow that I'll put briefly on your screen. I won't really go into too much detail on it, but a Node-RED flow that connects all the devices together. The integration was relatively easy to set up. All I did was set it up that anytime the brightness on the dimmer changes, the brightness on the cabinet LED strip changes, so they're kind of kept in sync. The only tricky thing I found really was integrating the Shelly i4, because all the Shelly i4 is just an input device, it's just a button. So whereas with the Shelly Dimmer, it has all different modes that we'll take a look at in a second around dimming up and dimming down and turning on at the minimum brightness, turning on at the maximum brightness, all that functionality. I had to manually implement that based on the button events coming from the Shelly i4. It was relatively easy to do though. I built all that in Node-RED, and now the Shelly i4 behaves basically the same as the buttons that are wired directly into the dimmer. I can hold it to turn the brightness up and down. I can click it to turn the lights on and off. If I hold it down when the lights are off, it'll turn on at full brightness, at lowest brightness. If I double press it, it turns up to full brightness. All that functionality now works, no matter whether I use the Shelly i4 or when the buttons wire directly into the dimmer. Finally, I've also been able to integrate it into my home automation system. So if I come in and the alarm's set and the alarm starts its countdown, so I've come in from outside with the alarm armed, the lights will automatically turn on so I can come into a light room. And when I leave, by setting the alarm, when I set the alarm, leave, close the door, the lights will automatically turn off, which is quite useful. Just a nice little quality of life improvement. The final thing that's worth bearing in mind is a mode that these Shelly devices have out of the box that might be undesirable. And that is, by default, you can reset the Shelly device by pressing the switch that's connected to it a number of times. And that confused me at first because I had the dimmers in here and I was playing about with them and I can't remember what was happening. I just remember pressing a button a bunch of times and then suddenly everything stopped working. And it turned out I pressed it enough times to factory reset the dimmer. And when you do that, it drops off your network, starts broadcasting an SSID again, and completely resets itself. This is easy enough to disable in the settings. There's just an option under the factory reset option to disable that behavior. So it's just worth bearing in mind and probably doing that once you've got these set up, so someone doesn't accidentally come along, get annoyed, press the light switch a bunch of times, and factory reset it. But with all that done, let's take a look at this working. So here we have the switch by the front door. If I press it, light will turn off. If I press it again, lights will turn back on. Not very exciting. Likewise, if I hold it, the lights will then dim down. Like that. And if I hold it again, the lights will dim back up. This is all default behavior of the dimmer, so that's not particularly exciting. And then if I turn it off, lights will turn off. If I hold it down with the lights off, whereas previously this would start dimming up and keep dimming up, I've set it up in Node-RED that if I'm holding it down and the lights were turned off, it will cap everything and keep it at the lowest brightness level. So now the lights have turned on, but they're at an extremely low brightness level. And I prefer this. I don't really care about dimming them up from the lowest level. What I care about is being able to walk into the hallway late at night, hold the button down, and turn the lights on very dim as a night light so I don't blind myself. And that's really, really useful to have. Once these are on, of course, I can hold it down and I can then dim them up, or I can double press it and it'll turn up to full brightness. So it's really, really useful to have that functionality. And of course, just to demonstrate this all working together, I'm now using the Shelly i4 switch next to the bedroom door. So this isn't wired directly into the dimmer. This is a separate device working through the home automation. But if I press the switch, all the lights turn off. That's both the cabinet and the lights in the room. If I hold it down with the lights off, all the lights turn on at a very low brightness and stay on the lowest brightness. If I double press it, the lights will turn up to the full brightness. And with the lights on, if I hold the button down, it'll start dimming them. So I can dim the lights down like that. And if I let go again, it'll dim the lights back up. Like that, so I'll dim up there. And then the way it's working here is because the cabinet's on a separate dimmer, once I've finished dimming the main lights that are connected to the dimmer itself, the cabinet then updates to reflect that brightness. So the cabinet doesn't dim in line with the rest of the lights. The rest of the lights dim, then the cabinet adjusts to reflect that. And that works absolutely fine. So yeah, that's the integration I set up in the hallway. And it works so well. So now the hallway's done. Now let's go and take a look at what we'll do in the living room and the bedroom. Okay, so here we have a switch in the living room. You've seen this before in other videos. But what we have here is we have a key switch that controls power to the actual smart bulbs themselves, and a kinetic wireless switch here that sends a signal into the smart home system to turn the lights on and off. So the plan for this will be to take this all out, put the Shelly device in here instead, and instead of the key switch, the lights will be switched through the Shelly. So the Shelly's relay will keep the lights on most of the time, but can be used to power cycle the bulbs if required. Then I'll replace this faceplate with a single gang one and just have a single module, which will be the retractive switch module that will also go into the Shelly, and I'll be using that as an input to the smart home system, and also through some Shelly scripts, I'll have it set up that if I hold that down or something, it'll automatically power cycle the bulbs. Still to figure out how all that will work, but we'll get the hardware in, and then we'll set that up later. So what we'll do now is we'll take this off the wall, take a look at the wiring we have here now, get the Shelly put in, take a look at how I've installed that, and then we'll go and set it up. Okay, so here we have the existing switch wiring. So what we have here is this is the end of line on the circuit. So there's only one permanent live. So the permanent live comes into the switch, and then out of the switch, this is out of the key switch, we have two switch lives up to the lights. That's because the lights in this room are wired in two different zones, because there used to be two separate switches here, one for the front of the room, one for the back. They're all smart bulbs now, so they're all just connected together. So two permanent lives, or two switch lives going up to the bulbs, so they all need to come out to be switched by the Shelly. Another switch live that goes up to the little in-wall touchscreen above here as well. That'll also be switched by the Shelly, just so I can restart that as well if I need to. So basically all of these will be going into the switched output of the Shelly. Then all the neutrals are just connected together in a Wago at the back, so I'll need to replace that with a larger Wago just so I can have an extra one for the Shelly as well. And then to connect the Shelly up, this has what are called dry contacts. So it means that you've got live and neutral here to power the Shelly, and then 0 and 1 are the switch contacts. So 0 and 1 will connect together when the relay's turned on. So because I wanted to switch live with this, what I'll need to do is put a link wire out of live into one of these, and then take the switch live out of that. It's because you could also say switch a low voltage signal with this or something like that, but because I want to switch live, I'll just need to put a link between live and into one of these relay contacts. So I'll get all this off the wall now and figure out how I'm going to do this. What I'll probably end up doing is putting a bunch of Wagos in here, because rather than trying to shove a bunch of these permanent lives into screw terminals on the back of switches and stuff, I might just stick a bunch more Wagos in here, just keep things simple. So yeah, I'll go away, figure it all out, and I'll come back and take a look once it's done. Okay, so I've now got it all wired up. I've not put the faceplate on yet, just because that would get in the way, because it would kind of hang off the earth, so I'll keep this out for now. I'll put that on in a minute. But it's fairly simple. Not the neatest thing in the world, but there's a lot of wires here to deal with, so this is the best I could really do. But what we have is the permanent live comes into the common on the switch, and then we come back out of the common on the switch into the live supply to the Shelly, so that just powers the Shelly permanently on. Then what we have on the Shelly is we have a link that goes between the live terminal and one of the relay contacts, and then the switched relay contact comes out and into this Wago, and this Wago is essentially all of the switched lives. So we have the two switched lives up to the lights, and the additional switched live that goes to the in-wall touchscreen. Then for the switch input, all we have is the switch live comes out of the retractive switch into the switch input on the Shelly, and then all the neutrals are just common together in the back in another 5-way Wago. So that's fine. It's not the neatest thing in the world, and the bedroom is going to be even more horrific because the bedroom's got an additional feed out to the next room, so that's going to be an additional cable, but it'll do. At least these are full, I think, 47mm boxes, so there's enough depth to fit all this. So I'll get this all sort of neatly put back into the box, get the faceplate on, and then we can fire it up. Okay, so it's now installed back on the wall, so now let's try it out. So as you see, we've got the switch here, all the lights are off. If I hold the switch down, the lights will all come on, and the touchscreen will power up, but if I let go of the switch, it all turns off again. That's because the Shelly is expecting this switch to be a rocker switch that latches into two different positions, not a retractive switch. So out of the box, that's not going to work, unless I want to stand here and hold the switch down to keep the lights on. So what it allows me to do is go into the Shelly config and reconfigure this to expect a retractive switch. And in fact, what I'll also do is I'll do what's called decouple the switch, which means that the switch won't directly control the relay anymore. The switch will act as an input into the home automation system to control the smart bulbs, and I'll have a script on the Shelly that controls the relay based on the switch input. So I won't have that direct coupling between the switch input and the relay that it has out of the box. So time to go away, get it all configured, and I'll take a look at it when it's all working. And we're back, and I've got it all set up. So the setup process, I've already described that previously with the hallway. It's fairly similar with this. Connect its access point, connect it to a network, do all the updates, and then disable the access points. This is no longer broadcasting its own access point, but it's just connected to my network. And it all works. So it's connected to MQTT, and I've added it into my existing Node Red float that controls all the lighting in this room. So I press the switch, the lights in the room all turn off. If I press it again, the lights in the room all turn on. And that's all I really care about. Now I've got a lot more flexibility with this. For example, I could add some functionality. If I hold this down, it dims the lights up and down. And that might be useful in some rooms, but in this room here, I've already got a little in-wall touchscreen, so I can just change the brightness on this. So I'd rather just keep this switch simple and do all the brightness and color temperature adjustment stuff on the touchscreens. So it works. But as I mentioned, I wanted to have some sort of override, especially now that I've removed the key switches that I previously used to use as an override. Well, I've implemented that, and I've done it through writing a script that runs on the Shelly. This is something that I mentioned when I first introduced the Shellys, and it turns out that when I mentioned earlier talking about the two different generations, the scripts are only available on the more modern Generation 2 devices. So the Shelly Dimmer and Shelly RGBW controller don't actually support scripts, but the newer devices such as the Shelly Plus ones that I'm using here do support scripting. So if you're going to use scripts, just make sure you buy devices that's compatible. But these scripts are little scripts, I think are JavaScript or something, that run locally on the device. And it allows you to set up automations that don't rely on any other part of your home automation system. And that's what I've done here. All of the lights in this room, including the touchscreen, all these devices, are powered through the relay on the Shelly. So what I've done is I've written a script that if I hold down this button for 10 seconds, give it 10 seconds, there you go. Power has been now cut to all the smart bulbs and touchscreens. So you can see the touchscreens turned off. The Shelly has actually killed the power. With the power off like this, if I then press the button again, which you won't be able to see, but if I press the button again, power will automatically instantly be reapplied to all the devices, and the bulbs have all turned on. And that works really, really well. So it means that in the event that I have a problem with the home automation system, the lights don't turn on or they don't turn off, I can still use this switch by holding it down to turn the lights off and clicking it once to turn it on. Additionally to that, I've also added functionality to the script, where if the Shelly isn't connected to MQTT, it works the same as I just demonstrated, but doesn't have that 10-second delay. Pressing it with MQTT disconnected will instantly turn the lights off, and then pressing it again will instantly turn the lights on. So if MQTT is disconnected, there's absolutely no chance of this ever working. It means either the MQTT server's gone down, the network's down, something bad has gone wrong. And at that point, this will work completely like a normal momentary light switch. I can just click it to turn the lights on and off without any delay. And that was really easy to set up in the script. I'll put a screenshot on your screen now just showing the script. Not going to go into too much detail, but the script is actually relatively easy to write. The documentation is pretty comprehensive. And with that, I've now got these switches without any ugly key switches next to them. And they work both as smart switches, but if I hold it down for long enough, I can use it as a manual override to kill power to the smart bulbs. It works so well. So there you go. That's a look at how I've upgraded my smart home with Shelly devices acting as smart light switches. And they work really well. So now I've got smart lighting as I demonstrated in the hallway, works absolutely brilliantly. And having these smart switches in the living room with a manual override that doesn't require a separate key switch next to them works super well. These Shelly devices are absolutely brilliant. Being able to use them with a self-hosted smart home system without any kind of cloud connection and without having to flash different firmware onto them, just being able to use a native firmware to connect to MQTT is absolutely brilliant. And the built-in scripting functionality on the newer devices is really useful for things like this override switch, where you want the device to still do something without any other input from your home automation system. In fact, you could probably do pretty complicated stuff with these without even ever needing to connect it to a network. So it's pretty good. So definitely pretty happy with them. And I've got a few upcoming projects where I'll also be using Shelly devices, so stay tuned for videos on those. But for now, what's left to say is thank you very much for watching.